All right. Now that you have some practice using radians, you might be wondering what tau is. You should be familiar with pi, which is the ratio between a circle's circumference to its diameter, or approximately 3.14. Tau is double that, approximately 6.28, and is defined as the ratio between a circle's radius and its circumference. Tau and pi are interchangeable when using radians. You simply must remember when converting that there is a factor of 2 between them. I prefer to use tau, as a full circle is 1 tau, whereas with pi, a full circle is 2 pi. This is due to how we define radians based on the radius. So far, you've actually been measuring angles by what fraction of a turn, rotation, or spin they are, then tagging tau onto the end of it. Now, we use tau or pi in our solutions to hide how ugly the decimal representation would be. This gives us the benefit of being able to quickly describe an angle based on how many turns it is, and also gives us some really cool benefits from the underlying radian structure. Let me tell you what a radian is. First, recall that arc length is some portion of a circumference. In our case, a portion of the length of the outside of a circle. We define one radian as the angle that carves out one radius worth of arc length. That's where it gets its name. A radian is the angle where the radius and arc length are equal. This gives us some really cool features, namely that your arc length equals your angle. Just multiply by the radius to scale it, which, when we write as a formula, is arc length equals theta times the radius. To help visualize tau, let's roll a circle out on a number line. If we measure out the entire circumference of the circle, we will see that a circle has 6.28 radians total. Now, saying a full circle is 6.28 is pretty cumbersome, and not any better than saying a full circle is 360 degrees. So what we do is we define 6.28 as a constant and call it tau. Now, we could have a radian measurement without tau. One radian, for example, is 57.2958 degrees. Not a particularly common angle that you might need to use. That's why we typically stick to measuring angles in number of or fraction of a turn, spin, rotation, and then just tag tau onto the end to make it in radians. And then, if we need the decimal expansion, we just plug it into a calculator at the end of our calculation.